Okay, let's take a look at another function where maybe building a table really helps us see what's happening with not only the function, but the function coming at it from both sides and looking at this idea of one-sided limits. So let's look at a piecewise function. One of the things you'll discover in calculus is your calculus teacher probably likes piecewise functions because they play so well with a lot of what we do in calculus. And I'm going to let this piecewise function actually have three pieces for this particular example. We're going to let the function look like 2x squared minus 3x for x values less than 2. And then when I get to x equals 2, I'm going to specifically define it as equaling 5 for x equals 2. And then the last piece, for x greater than 2, I'm going to let the function look like negative x squared for all x greater than 2. And as you can probably tell, the x value I'm really interested in discussing the limit of is 2. So I want to know, what is the limit as x approaches 2 of this particular function f of x? And again, I've got a piecewise function here that maybe isn't very easy for me to graph by hand, but if I have at least a piece of technology that can get me some table values, I can evaluate the limit, or at least estimate the limit going that way. So let's build ourselves a table. I'm going to look at x, and then also f. This should be an f of x values. So x and f of x values. And again, I'm going to approach 2. And so I'm going to start off with 1.9. And then I'll go to 1.99. So I'm getting closer and closer to 2. I'll go even one more and look at 1.999. I also want to consider what's happening at 2. And so I'm going to go ahead and put that on my table. And we already know that at x equals 2, the function is equal to 5. So I can go ahead and fill that point in on my table. And then I also want to kind of reflect this and mirror what I had going from the other way. So 2.001, 2.01, and then 2.1. And so what I'm going to do is I'm going to plug these into this function and then come up with the values and then see if we can say something about the limit. Well, for x equals 2, we already knew the function was 5. For these values over here to the left of 2, those values are less than 2, even though they're getting close to 2. They are less than 2. And so if x is less than 2, these values right here are going to get substituted into 2x squared minus 3x. And I've already got the values for you. You would probably want a calculator tool to come up with this. But f of 1.9 is equal to 1.52. 1.99, if I substitute it into this function, is equal to 1.9502, and 1.999, if I substitute it in, is 1.995, and that's a decimal that continues to go. So I can already look at this function here as I'm approaching 2 from the left. So I'm going to go ahead and write my limit statement here from the left. As I approach 2 from the left of f of x, the function values 1.52, 1.95, 1.995, the function values are approaching 2. So I can already write my left side limit by looking at these values of the table. And I can already see that that's different from the function at 2. But remember, when I look at limits, I'm not looking at 2, I'm looking at what's happening as I'm getting close to 2. So now let's come at it from the other way. If I substitute these values over here from the right, well, they're going to get plugged in because they're greater than 2. They're going to get substituted in to this function piece that's negative x squared. So if I take 2.1, square it, and make it negative, I get negative 4.41. And then if I take 2.01 and substitute it in, I get negative 4.0401. And then for 2.001, I get negative 4.004, and that goes on like that. So if I want to talk about what happens as I approach 2 from the right, the limit as x approaches 2 from the right of f of x. The function as I approach 2 from the right, these function values are approaching negative 4. And once again, we don't really care about, when we talk about these limit statements, we don't care about the fact that at 2 the function is defined as 5. In fact, I could have made this 50, and it's not going to change these limit statements right here. What it comes down to now is my one-sided limits don't match. And that defaults to our definition from topic 1.3. If the one-sided limits don't match, then that means the limit as x approaches 2 of f of x does not exist because the one-sided limits don't match. I can say something about the one-sided limits, but the limit as x approaches 2 of this function does not exist.